So we've been looking at atoms, and we've learnt that they're the smallest whole particle that makes up all the matter in the universe. They're the smallest whole particle. And we've been thinking of them as just one single sphere. A tiny particle, and it can join together to make molecules, and it can build up other materials. But we're now actually going to look at what's inside atoms. Because over time, scientists have discovered that there's actually smaller things that make up atoms themselves. So, the things that make up atoms are called subatomic particles. We have atoms are made of subatomic particles. And here are the three most important particles that we'll need to learn about. We've got positively charged ones, and these are called protons. We have other ones that are called neutrons, and these have no charge at all. And then we have negatively charged particles, and these are called electrons. So protons are positive, neutrons have no charge, and electrons have a negative charge. Protons and neutrons, we can see, are much, much bigger than electrons. So electrons are tiny, and in comparison, at least, we have protons and neutrons, and these are large. We're still talking smaller than an atom, but compared to electrons, they're a lot bigger. And remember that when we have objects that have a charge, an electrical charge, like if we have a proton and an electron, we remember that opposites attract. So a positive proton will be attracted to a negative electron. Protons and electrons are attracted. And this is an important idea to remember when we look at how atoms are actually built up and made. And that's what we'll do next. So let's look at the structure of atoms themselves. How do these subatomic particles make an atom? So this one, we've got a carbon atom here as our example. And carbon has the atomic symbol C, and its atomic number is 6. And here in our diagram we can see a few things. Firstly, we can see inside, in the middle of the atom, all the protons and neutrons are clustered and grouped together. And this is called the nucleus. It contains the protons and the neutrons. And because the protons and the neutrons are really big and heavy compared to electrons, the nucleus holds pretty much all of the weight, all of the mass of the atom. Holds nearly all the mass. Then around the nucleus, we've got, firstly, basically a lot of empty space. So there's just nothing in there, except also we have the electrons themselves as well. And the electrons, they fly around, and you can see on this picture, similar to planets orbiting around a sun. Except they're moving so fast that we can't see them, and we don't even think of them as being in one place. They're moving at the speed of light. And really, these days, the proper or the more accurate way to think of electrons is that they exist in just a cloud. They exist as a cloud of electrons. So they're never really in one place, but we can see up here in this picture, we think of them as just being in that space. They're flying around so fast that we just say they're in there somewhere. So that's a carbon atom. It's got, if we actually count now, it's got 1, 2, 3, 4, 5, 6 protons. It's got 1, 2, 3, 4, 5, 6 neutrons. And flying around the outside, we've got 1, 2, 3, 4, 5, 6 electrons. And remember, carbon is the 6th element. So we can see a big pattern here. Each element, depending on its number, that tells us how many protons, neutrons, and electrons there are in those atoms. So lastly, we're going to look at the proper way of writing atomic symbols. So we've already learnt before that every element has its own special symbol, and this is just a letter or 2 letters that represents it. So we've got C for carbon, but then on top of that, scientists also write the atomic number at the bottom left corner. And remember that carbon is number 6, and the atomic number tells us how many protons are there. And like we saw before, often it also shows us the number of neutrons and electrons too, but not always. Lastly, at the top here, we have another number, which is called the mass number. We can just think of it as the mass of carbon. And this number just tells us how many protons are there and neutrons added together. So basically we take the protons plus the neutrons. So for carbon, that was easy. We just, as we saw before, there's 6 protons and 6 neutrons. So the mass of carbon is 12, 6 plus 6. Here's a different element though. Let's compare it to Na. So Na is sodium. And we can see sodium's atomic number is 11. So it must have 11 protons in its nucleus. And we can see up here, the mass of sodium is 23. So this means we must have 11 protons. And to get to 23, there must be 12 neutrons in sodium. So normally the neutrons are the same as the protons. Sometimes there's 1 or 2 more, and sometimes 1 or 2 less. So remember, all atoms are made of protons, neutrons, and electrons.